This video is on modular or clock arithmetic, the basics, by Dr. Archie W. Earl. First, let us begin with a 12-hour clock. As you notice here, we have the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on a regular clock. In order to make a clock that we can do modular arithmetic on, we replaced the 12 with a 0, and we really have the numbers 0 through 11, and that's what we call mod 12. As stated, the 12 becomes a 0, so we would have the numbers 0 through 11, but there would be 12 numbers, so it's mod 12. So this is how the modular arithmetic clock looks. You use this clock to do your modular arithmetic. 0 represents the place of 12, and you have 12 numbers represented on the clock, and this is mod 12. If we were talking about mod 7, we would have 7 numbers on the clock, and those numbers would be 0, 1, 2, 3, 4, 5, 6. That would be 7 numbers that we would have on that clock, and that would be mod 7. So you can have virtually any positive natural number as a mod. We could have mod 1000. If we have mod 1000, we would have 0 through 999 on the clock for mod 1000. So once again, if you have a problem, you have to make a clock that corresponds to that mod. Let's see if we can make a clock for mod 7. We begin with the numbers 1 through 7. 1, 2, 3, 4, 5, 6, 7. And then we replace the 7 with a 0, and that will give us mod 7. So as you can see, that's what I've done there. In order to have a clock in mod 7 that I can do my modular arithmetic on, I have replaced the 7 with a 0. So I have 0, 1, 2, 3, 4, 5, 6 when I'm dealing with mod 7. There's no 7 in mod 7. The highest number you can have is 6. Alright, now that we know what we mean by mods and how to create our modular clocks, let's look at the steps for doing modular arithmetic. Step 1, perform the operation. If you have addition, you do the addition. If you have multiplication, you do the multiplication first. Secondly, step number 2, you have to divide the mod to get the number of complete revolutions. you divide the mod into the number. So if you have like 59, you want to know what that is in mod 7. You divide the 7 into the 59 so that you can determine how many total revolutions you have, how many times you have to go around. And then the remainder will tell you the additional moves that you have to make after you go around the total number of revolutions. And the answer to the problem in modular arithmetic is where you end up on the clock. That's what the answer is. So you have to look at where you are on the clock. If you're in mod 7 and you end up on 3, the answer would be 3. If you're in mod 7 and you end up on 6, the answer would be 6. So wherever you end up when you're doing modular arithmetic, that would be the answer to the problem. So once again, you perform the operation, divide the mod into the number so that you can figure out the total number of full revolutions, and the remainder will be the additional steps. So you take the clock, you go around the full number of revolutions, and then after you do that, you go the additional steps. And where you end up, once again, that would be your answer to the problem. So modular arithmetic is very interesting arithmetic because you don't get the answers that you usually get in ordinary arithmetic. For example, if you add 5 plus 11 in ordinary arithmetic, you would get 16. But if you add 5 plus 11 in mod 6, you would get something different. So what you get when you deal with modular arithmetic depends upon what mod you're in. Alright, now that we have the steps, let's look at some examples. You should copy these examples in your notebook because we're going to go over these. First of all, we want to find 28 plus 9 in mod 7. We want to figure out what that will be in mod 7. Next, we want to find out what 3 times 8 is in mod 7. We know in ordinary arithmetic 3 times 8 would be what? If you said 24, you're right. But in mod 7, it would be something different. If you're in mod 3, it would be something different. If you're in mod 2, it would be something different. So that's what you have to be concerned with when you're working in these different mods. And of course you can have just a plain number that you want to convert to a certain mod. You don't have to have an operation. I could have 35 mod 7, and I want to figure out what that is. I want to find 35, what 35 would be in mod 7. Alright, let's look at the first example. First example, we have 28 plus 9 mod 7. So the first thing we want to do is perform the operation. The operation is addition. In this case, we add the 28 plus the 9. And 28 plus 9 will give us 37. So now that we have the 37, we know we're dealing with mod 7, so we make a clock for mod 7. And that's what I have here, a clock for mod 7. And that's what we're going to use to get the final answer. Now, as stated, after you multiply or add, whatever the operation is, and in this case, it's addition, 28 plus 9 will give us 37. We have to divide the 7 into the 37 to see how many complete revolutions we have, because we're dealing with mod 7, as you can see there. And notice here that we have 3 bars between the two equations, and the 3 bars they mean identical to or congruent to. That's what we usually use when we talk about mods. But of course, it means basically the same thing as equals. Alright, so we divide 7 into 37. We get the full number of full revolutions. And 7 will go into 37 how many times? If you said 5, you're correct. 7 goes into 37 5 times. So as you can see, that's what I've done here. That means that we will have 5 complete revolutions. So we have to go around the clock. We always start on 0 when we're doing modular arithmetic. We start on 0, and then we would go 5 revolutions around the clock. That's the 5. That represents the total number of revolutions. And once again, you divide the mod into the number, and the remainder is the extra. That's the additional moves that you have to make. So the remainder in this case is 2. So as you can see here, I've already gone around 1 2 times, so I need to go around 3 more times because you have 5 complete revolutions. So I'm going to go around here 3 more times, and after that I'm going to look at my remainder and go the additional amount. That's 1, 2, 3, 3 additional trips, and then I go the additional amount, which is 2 units. So I end up at 2. So that's my final answer. That means that 37 is equal to 2 mod 7, which means 28 plus 9 mod 7 is congruent to or identical to 2 mod 7. That's what 37 would be in mod 7. It would only be 2. So once again, when you're working in a certain mod, you can only get numbers that are on the modular clock. My possible answers to problems involving mod 7 are 0, 1, 2, 3, 4, 5, 6. Those are the possible answers. I would have to end up at one of those numbers when I do my modular arithmetic. So as indicated here, we had 5 revolutions. We went around 5 times, and the remainder was 2. So we had to go 2 additional moves, and we ended up at 2, which was the answer to the problem. So once you do the revolutions and the additional moves, the answer is very, very simple. It's wherever you end up. Alright, let's look at the next example. In the next example, we have 3 times 8 mod 7. We want to know what 3 times 8 would be in mod 7 once we simplify it. Now in mod 7, it has to be, the answer has to be 0, 1, 2, 3, 4, 5, or 6. We have to end up on one of those numbers. So as you can see here, number 1, my first step, I do the operation. And the operation this time is multiplication. I have 3 times 8. That would give me 24. After you do the operation, then you have to divide the mod into the number, and that will tell you the total number of revolutions that you have around the face of the clock. So here I have to divide 7 into 24. Think about it. How many times will 7 go into 24? If you said 3, you're correct. 7 will go into 24 3 times. So that means we're going to have 3 complete revolutions. And after you multiply and subtract, you have the remainder. And what would the remainder be in this case? If you said 3, you're correct. The remainder will be 3. So here you can see what I did to get the number of complete revolutions. Once again, we're working with mod 7, so I had to divide 7 into 24. And 7 goes into 24 3 times. So that means we will have three complete revolutions. We always start at 0 for modular arithmetic. We would go around 1 complete revolution, 2 complete revolutions, 3 complete revolutions. At that point, we're at 0. Then we have to look at the remainder. The remainder tells us that we have to make 3 additional moves. So we just go 1, 2, 3. And as you can see here by looking at the mod 7 clock, I will end up at 3. As I stated, you start at 0 and you go the total number of complete revolutions first. So we had 3 complete revolutions. So we're going to start at 0, go around once, twice, 3 times. And then we look at the remainder. The remainder tells us the additional moves that we have to make. The remainder is 3, so we go to the right, 1, 2, 3. And we end up, class, at 3. That's the answer to the problem. Wherever you end up, that's the answer to the problem. So that means that 3 times 8 mod 7 is identical to or congruent to 24 mod 7, which is equal to 3 mod 7. So that's what I've written down the bottom here. We have 3 times 8 mod 7 is identical to 28 mod 7, which is identical to, or that was 24, right? 3 times 8 is 24. So that's 24 mod 7, which is identical to or equal to 3 mod 7. So that would be the answer to the problem. The answer would be 3 mod 7. That's what 24 is equal to in mod 7. 24 as a regular number in our number system is 24, but in mod 7 it corresponds to 3. So as indicated, if you're in mod 7, your answer has to be one of those numbers. Your answer has to be 0, 1, 2, 3, 4, 5, or 6. And notice once again, when you're working with mod 7, 7 is not on the face of the clock. 0 takes the place of 7. Alright, let's look at our final example. In our final example, we had 35 mod 7. We had to figure out what that was equal to, what 35 was equal to, or is equal to, in mod 7. So the first thing we have to do is divide 7 into 35 to see how many complete revolutions we have. How many times will 7 go into 35? If you said 5, you're correct. 7 will go into 35 5 times. And what would the remainder be? If you divide 7 into 35, what would the remainder be? If you said 0, you're correct. So as you can see here, we divide the 7 into the 35. It goes 5 times. That means that we will have 5 complete revolutions. There's no remainder. So that means we don't move any additional units around the clock. Once we go around 5 times, that's it. That's the answer to the problem. So as you can see here, I started at 0 and I went around this clock 5 times. And when I did that, since I didn't have any additional steps, I ended up at 0. So I went around run 2, 3, 4, 5 times. And I ended up back at 0. So the answer, once again, is where you end up. So you can see here that I ended up at 0. So that means my answer would be 0. Which means, class, that 35 mod 7 is identical to or congruent to 0 mod 7. Now that we have seen some examples of modular arithmetic or clock arithmetic, now it's time for you to do some of these problems. These are the homework problems that you have for modular and clock arithmetic. Problem number 1, you want to figure out what 31 is mod 8. Now you can't use the clock for mod 7 to do mod 8. You have to make a clock yourself for mod 8, and then you have to perform the steps that we mentioned and decide what and figure out what 31 would be in mod 8. The second problem, we have 19 plus 12 mod 8. You want to figure out what that would be. You want to simplify the answer. Be sure to perform the operation first. The next problem, we have 5 times 6 mod 8. So you have to perform the operation. Then you have to look at the clock for mod 8 to figure out what your answer will be. The fourth problem, you have 32 mod 8. You want to simplify that, figure out what 32 would be in mod 8. And all of these problems, as indicated, first you determine the number of total revolutions by dividing the mod into the number. And then that would give you the total number of revolutions. And then you look at the remainder. The remainder tells you the additional moves that you have to make after you go around the total number of complete revolutions. And once again, class, where you end up, that's your answer to the problem. Problem number 5 is a manipulative problem. You have to create your own manipulatives. You have to make a clock for mod 4 and mod 15. And you have to submit these clocks along with your assignment.